An overriding goal of worksite operations is that there be no accidents and that traffic flow unimpeded. Neighboring businesses, homeowners, and others should feel only a minor effect. How can this come about? Engineers must develop a careful, detailed traffic control plan, and it must be carried out faithfully. Traffic control plans are required for any large-scale, long-term construction projects. Moreover, they are required for all federal aid projects. In this program, we will see how to develop an effective traffic control plan. We will follow the process from pre-planning through the actual design and writing, the implementation, evaluation, and even revision. Each step in the process is important. The plan includes traffic control strategies, staffing requirements, use of specific devices, and the design of geometric features such as tapers. In short, it is a blueprint for handling traffic through the work zone. The plan is created by a team of highway agency officials. They may be central, district personnel, or even occasionally from the resident engineer's office. And they follow this procedure beginning with pre-planning. Before the construction project budget is approved, the team makes a site visit. They must determine what overall strategy to use. Will the work require an elaborate detour of traffic out of the entire area? Or can the work be done while maintaining through traffic? In considering these questions, the team must think in terms of the basic principles covered in the videotape Work Zone Safety Concepts. Namely, how can safety be maximized while minimizing public inconvenience? Next, they must address more specifics. If traffic can continue through the work area, how will it be handled? Will it be routed onto the shoulder? Or will this work require closing one or more lanes of traffic? Often, sketches and notes taken in the field prove valuable later. They should pay special attention to pavement shoulder drop-off policies. Any drop-off is considered hazardous, but those greater than 5 centimeters left overnight and immediately adjacent to traffic have a high accident potential. Other questions to answer when considering how to handle drop-off are: how much traffic volume will there be? How far will the drop-off be from the traveled lane? How many days will the drop-off remain? And what will be the shape of the edge or slope of the drop-off? The plan may have to require paving or creating a wedge of gravel or other material to reduce the drop-off. The team should have a knowledge of speed control policies for their department. This includes the establishment of speed limits and the enforcement procedure. And finally, there must be policies for accident monitoring before, during, and after work activity. Once back at the office, they use notes, sketches, and standard references, as well as knowledge and experience, to create the plan on paper. It will begin with an analysis of possible traffic management strategies, and an explanation of the strategy chosen as the most efficient. There is a 9-step process leading to the selection of an appropriate work zone traffic control strategy. First, they assemble data. There are 3 areas to consider. The construction project itself. What type of work is going to be done? How much space is required? What is the schedule? How much money will it cost? Next, they consider traffic data. What are the 24-hour volume counts? What speed does the traffic usually travel at? Are there potential detour routes? Finally, there is roadway data. Where are right-of-way boundaries? What are the horizontal and vertical curve profiles? Are there existing traffic control devices? What is the adjacent land use? With all data assembled, the team can concentrate on the next step, determining the extent of roadway occupancy. It is necessary to determine which lanes or portions of lanes will be closed, as well as how long they will be closed. In short, what is the expected roadway capacity reduction? For the 3rd step, they must identify which strategies may be appropriate for this work activity. Strategies include lane width reduction, lane closure, median crossover, temporary bypass, detour, intermittent lane closure, and use of shoulder or median. 4th, they must analyze volume and capacity relationships. All the alternatives will reduce available capacity and produce congestion. The higher the traffic volume, the more severe the potential impact of the work zone. They must consider how the planned work zone traffic will affect flow capacity of the roadway. Next, the team must decide if capacity problems exist. If they do, then the 5th step is to analyze capacity improvement techniques. In other words, apply a technique that may reduce delay and congestion, such as do work at night, restrict work to off-peak hours, postpone work to off-season, work only on weekends, use reversible lanes, or modify signal timing. For step 6, they must define the actual alternatives, which means pick the practical alternatives, and throw out those that are not feasible on the basis of volume and capacity relationships, or are cost prohibitive. 7th, they must quantify the impact of these alternatives. A cost-benefit analysis requires real numbers. In other words, how much traffic will be delayed? How much extra fuel will be consumed? How much air pollution will there be? Or how much business loss will there be? Once again, if there are problems, as step 8, the team must make changes. Some of the impacts may be very severe for all of the alternative strategies. Often, a scheduling modification, such as restricting work to off-peak hours, may solve the problem. For the last step, they select the best alternative. It will be the alternative with the least anticipated impact. The traffic control plan should show the traffic control device layout for the selected alternative. Here are some examples. For a rural 2-lane highway, for an urban arterial, for an intersection, and for a freeway. When the plan is ready, it should be reviewed by both in-house highway agency and funding agency personnel. Once the traffic control plan is written and approved, the obligation for traffic control is assigned to a project-level field engineer called the responsible person. Responsible persons should be trained in work zone traffic control and safety engineering. These engineers should be certified by the American Traffic Safety Services Association or another appropriate agency. Their primary concern is traffic control. They should have the authority to ensure that provisions of the plan are carried out in the field. These engineers may have several sites they are responsible for. In addition, crew supervisors continually inspect while agency personnel check each site daily. A traffic control plan calls for an initial inspection to ensure compliance. Let's look at how an initial inspection goes. The engineer would first make contact with the supervisor on location and then perform a walkthrough, comparing the actual layout with drawings in the traffic control plan. Are the advanced signs and barricades the proper distance apart? Are the signs within the project the standard colors and size? Have they faded or become worn and illegible? Are the signs in the proper position? And do they still have adequate retroreflectivity? The engineer should check the same items regarding drums. Then, looking at pavement markings, determine if they are the standard color and if they will be visible at night. Do warning lights conform with standards? Any deficiency should be noted by the type of device and nature of the deficiency. Subsequent inspections may be done as a drive-through, and there ought to be inspections at night. On-site inspections are not the only way traffic control plans are measured. To evaluate the impact of the plan, there is also a cost-benefit analysis. It is based on a series of measurements, including accidents. The estimated work zone accident rate is directly related to the accident rate prior to construction and the average daily traffic on the route. Vehicle delay. The estimated travel time through the work zone is compared to the optimum travel time on the same roadway when it is not obstructed. Vehicle stops. Where a reduction in highway capacity occurs due to construction activity, vehicles can come to a complete stop, resulting in considerable traffic backups. Traffic engineers determine the number of stopped vehicles in a given highway segment. Vehicle operating cost. Increased vehicle operating costs are related to speed reductions due to highway construction activity. The key cost element is lost fuel efficiency. Air pollution. The number of tons of emissions are the typical measure of air pollution. In an analysis of work zone impacts, the amount of emissions is based on average speed data. Traffic control costs. This refers to the amount of money spent on traffic control devices for the work zone. In-place rental charges are generally assessed by subcontractors for barricades, lights, signs, arrow boards, barrels, and cones. Traffic control planning is not over even when the work is complete and the work zone is removed. It is an ongoing process. A safety review is performed annually. It includes all roadway activities, with an emphasis on nighttime operations and device retroreflectivity. The safety review involves a high-level review team composed of a state traffic engineer, resident construction engineer, and Federal Highway Administration engineers. These reviews sometimes uncover data leading to the revision of traffic control plan policies and standards. For instance, accidents within the project limits may be too frequent. There may be evidence of driver confusion, or perhaps work sites have been the cause of major disasters, such as chemical spills. In this program, we have seen how a team of engineers develops an effective traffic control plan. Each step in the process of creating a traffic control plan is important. The plan includes traffic control strategies, staffing requirements, use of specific devices, and the design of geometric features such as tapers. In short, it is a blueprint for handling traffic through the work zone. The process begins with pre-planning. Before any equipment or personnel get to the site, the team makes a site visit. They must determine what overall strategy to use. Will the work require an elaborate detour of traffic out of the entire area? Or can the work be done while maintaining through traffic? In considering these questions, they must think in terms of the basic principles covered in the videotape Work Zone Safety Concepts. Namely, how can safety be maximized while minimizing public inconvenience? The next step is the actual design and writing of the plan. Once back at the office, they use notes, sketches, and standard references, as well as knowledge and experience to create the plan. It begins with an analysis of possible traffic management strategies and an explanation of the strategy chosen as the most efficient. At this point, the traffic control obligation is assigned to a responsible person, a certified engineer. This engineer's primary concern is traffic control. This engineer should have the authority to ensure that provisions of the plan are carried out in the field. These engineers have several sites they are responsible for. Crew supervisors perform frequent inspections, while agency personnel check each site at least once a month. The initial inspection should be a careful walkthrough. After that, they may be drive-throughs by day and night. There are also cost-benefit evaluations and periodic safety reviews. For more information, check the National Cooperative Highway Research Program synthesis of traffic control plans. For more information on other IRF videotapes, call the International Road Federation at the numbers on your screen.